Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we start on today's lesson, I'd like to ask you to please subscribe to the channel, give this video a thumbs up, and engage with a comment below. Today we're looking at Unit 6, Introduction to Quadratic Functions, Lesson 12, Graphing the Standard Form, Part 1. The learning goal today says let's see how the numbers in expressions like negative 3x squared plus 4 affect their graph. We have two learning targets today. As we go through the practice problems, please keep these in the front of your mind. When we're done with them, we'll come back, review these learning targets, and make sure that you understand everything you need to as we move forward. Learning target number 1 says I can explain how the A and C in y equals ax squared plus bx plus c affect the graph of the equation. Learning target number 2 says I understand how graphs, tables, and equations that represent the same quadratic function are related. Our first practice problem says here are 4 graphs. Match each graph with a quadratic equation that it represents. So what I would like you to notice, if you look down to the bottom right, in every single one of these, we have y equals x squared. So the A term never changes. It's always 1. The only thing that is changing is the amount that we're adding or subtracting. In the first one, we don't add or subtract anything. In the second one, we add 5. In the third one, we add 7. And in the fourth one, we subtract 3. So if you don't know what it is that the C term does yet, think about this. I have one graph where it looks like I'm not doing anything to it. I have 2 graphs where it looks like I'm adding, and one graph where it looks like I'm subtracting. Well, look back up at the graphs. Graph A goes down into the negatives. Graph B sits right at the origin. And graphs C and D both move up into the positives. It turns out that the C term is your y-intercept. And if you think about it, a y-intercept is always going to have an x value of 0. So if I put 0 in for x, then 0 squared is 0. All of the x squared terms go away, and I'm left with 0, 5, 7, and negative 3. Those are their y-intercepts. So if I want to match these, then I can see on graph A, my x-intercept is down here at negative 3, 0. So graph A must match up with equation 4. Graph B. We see that the y-intercept is right here at the origin, 0, 0. So that means graph B must match up with equation number 1. Graph C, we can see the y-intercept right here at 7. Oh, I wrote all of these backwards. This is 0, -3, 0, 0, and 0, 7. So now if I look, that means graph C must match equation 3. And the last one, graph D, we see the y-intercept right here at 0, 5. That means graph D must match equation 2. If you have any questions about what the C term in a standard form quadratic equation tells you, please leave a message below and I'll get back to you with any help that I can offer. Our next practice problem says the two equations y equals the quantity x plus 2 times the quantity x plus 3 and y equals x squared plus 5x plus 6 are equivalent. Number 1 wants to know which equation helps find the x-intercepts most efficiently. So for number 1, what you need to know is that x-intercepts need the y value to be 0. Because I want the y value to be 0, I would use the factored form. So the factored form lets you set x plus 2 equal to 0 and x plus 3 equal to 0 to find the x-intercepts. Now, for number 2, it asks which equation helps find the y-intercept most efficiently. And what you need to remember is that y-intercepts need the x value to be 0. The standard form lets you set x equal to 0, leaving just the c term, which is the y-intercept. So we would say y equals 0 squared plus 5 times 0 plus 6, which just equals 6. So depending on what it is that you're looking for, you may want one equation instead of the other. So if what you're trying to find is the x-intercepts, then you want to use the factored form. Set each factor equal to 0, and you find your x-intercepts. If, however, what you're wanting to find is your y-intercept, then you're going to want to use the standard form, because in the standard form, the c term is the y-intercept. Because as soon as you try to plug 0 in for x, the only thing that's left is the c term. If you have any questions about this practice problem, please leave a comment below, and I'll get back to you with any help that I can offer. Our next practice problem says here is a graph that represents y equals x squared. As you can see, this is our generic quadratic equation resulting in a parabola that opens upward with its vertex at the origin 0, 0. On the same coordinate plane, they want us to sketch and label the graph that represents each equation. So for number 1, we see that the only thing that changes is the minus 4. So the a term here is a positive 1, and this means that it's going to open upward. The c term here is a negative 4. And this means we're going to shift down 4. So I can take my vertex from the origin and I can move it down to negative 4. Now, I need a few more points, and you can either just try to eyeball this and shift it down, or you can go ahead and pick some numbers. So I know that if I put 2 in there, 2 squared is 4, and 4 minus 4 is 0. So I'm going to have x-intercepts at 2 and at negative 2. Then if I were to put 4 in there, 4 squared is 16, minus 4 is 12. So I'm going to have a point at 4, 12, and another one at negative 4, 12. And then I can go ahead and connect the points. And that would be the graph for number 1. Number 2. In this one, we can see that we have a change in the a term and we have a change in the c term. So the a term in number 2 is -1. The negative a term tells us that this should open downward. So we're going to flip it upside down. The c term, being a +5, tells us that we're going to shift it up 5. So instead of starting at the origin, it's now going to start at 5. And then it's also going to open downward. So to get some other points, if we put 2 in there, then 2 squared is 4. -4 plus 5 is going to be +1. So we've got a point at +1 for 2 and +1 for -2. If we go out to 4, then 4 squared is 16. Now we have -16 plus 5 is -11. So we're at 4, -11, and we're at -4, -11. And now we can go ahead and connect our points. And now we have the graph for number 2. So the important things to take away from this practice problem is that a positive a means it opens upward, a negative a means that it opens downward. A positive c term means we shift it up that many, and a negative c term means we shift it down that many. If you have any questions about how to do a practice problem like this, please leave a comment below, and I'll get back to you with any help that I can offer. Our next practice problem says select all equations whose graphs have a y-intercept with a positive y-coordinate. Now we have a mixture of equations here. Some of them are standard form, and some of them are factored form. We can do the standard form first because they are the easiest to answer this question. In standard form, the c term. So standard form is ax squared plus bx plus c, and it's that c term that is the y-intercept. So as we look, a is in standard form. The y-intercept here is -2. We wanted a positive y-coordinate, so A is incorrect. The next one that's in standard form would be choice B. And if you notice, we have the x squared term, we have the x term, but then we don't have a c term here. If we don't have a c term at all, then it's understood to be 0. So the y-intercept here is 0. And 0 is not positive nor negative. So B is incorrect. Option C is in factored form, so we'll come back to that one. But option D is in standard form, ax squared plus bx plus c. In this case, c is negative 5, so that means the y-intercept is at negative 5, and we want positive y-coordinates. So D is incorrect. Now, the other two choices here are in factored form. And if it's in factored form, then we need to let x be 0. Because if I'm on the y-axis, then my x value is 0. So that means choice C is going to be 0 minus 1 squared, which equals negative 1 squared, which is positive 1. And we wanted positive y-coordinates, so C is a correct choice. Our last option is choice E. Again, this is in factored form, so we're going to let x be 0. That means that we have 0 plus 1 times 0 plus 2. 0 plus 1 is 1. 0 plus 2 is 2. And 1 times 2 is 2. That's a positive y-coordinate, so that means E is our other correct choice. If you have any questions about any of the practice problems we went over in Lesson 12, please leave a comment below and I'll get back to you with any help I can offer. Before we finish this lesson, let's go back and take a look at the learning targets and make sure that you understand everything you need to moving forward to the next lesson. To finish up this lesson, let's look back at these learning targets and make sure you understand both of them. Learning target number 1 says I can explain how the a and c in y equals ax squared plus bx plus c affect the graph of the equation. If you remember, when a is positive, that tells us the parabola is opening upward. When a is negative, that tells us the parabola is opening downward. When we look at c, if c is positive, that tells us how many units to shift the parabola up, and if c is negative, it tells us how many units to shift the graph down. Learning target number 2 says I understand how graphs, tables, and equations that represent the same quadratic function are related. So you can use tables of values to create the graphs. You can use equations to create the graphs. You can use equations to fill out your table of values. You can use graphs to find your equations and fill out your table of values. It doesn't matter which type you're given, you can use it to create the others because they all represent the same thing. And some of the key features that you can find in each are the x-intercepts, the vertex, and the y-intercept. You should be able to find all 3 of those features using graphs, tables, and equations. If you understand all of this, you're right where you should be, If you have any questions, please leave a comment below, and I'll get back to you with any clarification that I can offer. On the screen, you should see a video that YouTube believes will be helpful to you. If you found this video helpful, please hit the subscribe button, give this video a thumbs up, and I look forward to seeing you in the next lesson.